Flood risk datasets are tools that provide a better understanding of the flood risks for a given watershed. These datasets are represented in the Flood Risk Database, the Flood Risk Report, and the Flood Risk Map. This slide provides a summary of the types of flood risk datasets, such as changes since last firm, depth and analysis grids, the flood risk assessment, and areas of mitigation interest. The datasets listed in red are enhanced datasets and are dependent on data availability and watershed needs. Flood risk datasets can be used for visualizations of depth and analysis grids. They can show the changes since the last firm, comparisons, show risk assessment results and areas of mitigation interest overlays, and show ad hoc query results. The changes since last firm dataset depicts the areas where flood hazard boundaries have changed since the last map update. It's created by spatially comparing a community's flood insurance rate map with data created through RiskMAP. The changes since last firm polygon dataset depicts changes in the 1% and 0.2% annual chance floodplains and floodways as a result of new and/or updated engineering or redelineation from the prior effective firm to the firm panels being updated with the RiskMAP project. This dataset only defines change in the horizontal direction. It does not describe changes in flood depth. There is a water surface elevation change grid for that purpose. Each polygon contains attributes identifying the previous flood zone and the current flood zone. There are also attributes that indicate why the floodplain may have changed. This dataset also documents the types of topographic data and models used to create the two special flood hazard areas, as well as what contributing engineering factors may have caused the changes, such as change in topography, modeling method, erosion, the number of hydraulic structures, or the peak discharges used. This allows users to understand both where the changes occurred and why. The changes since last firm dataset is a spatial dataset that provides information regarding changes made to the special flood hazard area and floodway boundaries during the course of an updated study. This graphic is an example of what the changes since last firm dataset will look like. The call-out box in red demonstrates where there are gains in the special flood hazard area, and the call-out box in blue demonstrates where there are losses in the special flood hazard area. In this example, the changes in the floodplains are based on preliminary data and are not final. The features and benefits of this data set include capturing the changes in the floodplain and floodway, as well as the flood zone designations, helping identify reasons for the changes in the extents of the special flood hazard area, helping focus on flood risk areas that may need greater attention, assisting in prioritizing mitigation actions, assisting with potential modifications to evacuation plans and emergency action plans, assisting the public in determining their locations relative to the special flood hazard area. The intended users for this database include community officials and leaders, planners, engineers, developers, insurance agents, realtors and lenders, and citizens. The changes since last firm dataset, which is provided to help communities understand the extent of the changes in the special flood hazard area since the previous firm was published, can help mitigation planners understand areas that are at greater flood risk for future plan updates. It also helps local floodplain managers and building officials understand areas that will fall in or out of development regulations per local floodplain damage ordinance that they are tasked with enforcing. In addition, the changes since last firm assists insurance agents, citizens, real estate professionals, and lending institutions in understanding which areas fall in or out of the National Flood Insurance mandatory purchase requirements once the firms are effective. The changes since last firm communicates the changes to the firm and the reason for the change, for example, new terrain data, hydrology, or development. The flood depth and analysis grid dataset will help communicate the flood depths in an identified flood hazard area and the potential for flooding in these areas. One of the main purposes of the flood depth and analysis grids is enhanced communication about risk. People understand 5 feet of floodwater depth as opposed to a BFE of 112. It's easier for them to visualize and understand the risk and how it may relate to their property and safety. Mitigation planners and emergency responders can use the various grids to screen for potential projects or gain insight into locations that may affect emergency response, such as roads that are overtopped by various frequency events. The depth grid types, depth, probability, and velocity, describe different facets of flooding: how deep, how often, and how fast. The firm floodplain boundary describes a location as either in or out of the floodplain. The flood depth and analysis grids show the degree of risk, such as how deep for a particular frequency or how often flooding is likely to occur. Flood depth and analysis grid datasets provide a wide variety of information associated with determining and visualizing flood risk. Examples of the multiple datasets are shown on this slide. The flood depth grids can be developed for 10, 4, 2, 1, and 0.2% annual chance flood events. In addition, the percent chance of flooding in any given year and the percent chance of flooding during a 30-year period can be communicated. The features and benefits of these datasets include identifying the relative risk within the special flood hazard area, indicating the percent annual chance of flooding over an average mortgage or 30-year time period, assisting with mitigation prioritization based on risk, assisting with cost-effectiveness screening for potential development, creating a visual tool to communicate risk to the public. The intended users for the flood depth and analysis grids include planners, officials preparing mitigation grants, elected officials and local leaders, homeowners and home buyers, and realtors. These datasets can help communities better understand more characteristics of their floodplains in addition to the standard 1% annual chance flood zone information. It visually shows level of risk within the same floodplain and depths of flooding for multiple return frequencies at any location. It is a powerful communication and planning tool, enabling users to convey that a property may not just be in or out of the 100-year floodplain, but that it may receive a specified level of flooding from an event of lesser magnitude. Using the depth for a 25-year event, simple depth-to-damage curve calculations can be applied to tell a particular property owner that in a particular event they can expect a specified amount of dollar damages. The flood depth and analysis grids can also assist with enlisting the support of elected officials and local leaders by identifying areas of highest flood risk according to frequency and magnitude for possible mitigation actions, even if the action is to maintain open space. They can also help building officials, property owners, and developers understand the elevation requirements for specific sites according to local flood damage prevention ordinances and how those might change over time. This example demonstrates the ways that community officials can use flood risk database to generate maps for specific needs. This map was generated to focus on a specific area of the community to assess flood risk. Depicted on this map are the estimated depths for the 10% annual chance or 10-year flood event, stream flow constrictions, land use changes, and dams. This map depicts the estimated depths for the 4% annual chance or 25-year flood event. This map depicts the estimated depths for a 2% annual chance or 50-year flood event. This map depicts the estimated depths for a 1% annual chance or 100-year flood event. The depth analysis grids on this slide represent the percent annual chance grid and the likelihood of flooding during a 30-year mortgage. The percent annual chance grid predicts the risk of flooding in any 1 year. The likelihood of flooding during a 30-year mortgage period illustrates the risk of flooding during a 30-year mortgage. This is an example of a percent annual chance of flooding dataset with aerial imagery. From this dataset, the estimated risk to a given parcel and structure can be defined. This is an example of the percent chance of flooding during a 30-year period grid with aerial imagery. This is especially useful to communicate the flood risk for a given area over the time period of many mortgages.